Hey class, this video is going to go with section 12.3a, and today we're going to be talking about the normal distribution. And the normal distribution you've probably heard of before. If something is normally distributed, it follows this nice bell curve. So does bell curve sound familiar? So today's goal is that you can use the mean and standard deviation of the data set to fit it to a normal distribution and then use that to estimate population percentages. So here is a diagram of the normal curve. So if data is distributed normally, then we can say that the average, the mu, remember mu means mean or average, lies in the middle. It's right in the middle of the bell curve. And then 68% of the data lies between one standard deviation from the average. So remember, this is what the symbol sigma is what we use to represent the standard deviation. So 68%, if it's normally distributed, lies between one standard deviation of the average, which means there's 34% to the right and 34% to the left of the standard deviation. And then 95% of the data actually lies between two standard deviations of the mean, which means that there is out here the 13.5% between one and two standard deviations, and then 13.5% to the left. And I'll show you how we get those numbers in a second here. And then if it's normally distributed, we can say that actually almost all data, 99.7%, lies between three standard deviations of the mean. So almost 100%, 0.3 away from 100% will be within three standard deviations of the average if it's normally distributed. So that's pretty neat. It's very common. It's probably one of the most used statistics, distributions. And so I'll show you how we get these percentages and then how we use it today. So here is a normal curve, and I'm going to assume it's normally distributed, and then I'm going to put those percentages in there and show you how I calculate them. So first we draw our middle line, and that's where our average will go, and then we go three standard deviations to the right, so 1, 2, 3, and three standard deviations to the left, 1, 2, 3. And then 68% of the data will lie between one standard deviation, so one to the right and one to the left. So if the standard deviation is 0, or if the mean is 0 and the standard deviation is 1, then 0 plus 1 and 0 minus 1. So one standard deviation. And then I get the percents in each category, or in each area under the curve, by taking the 68 and dividing it by 2. That's where I get 34% to the right and 34% to the left. And then 95% of the data lies between two standard deviations of the mean. So between 2 and -2 if the standard deviation is 1 and the mean is 0. So 95% lies between two standard deviations, and then I can figure out what goes under the curve in each of those boxes. If I take 95 and I subtract 68, that leaves me with 27% between those two. So 27 then divided by 2 is the 13.5. So that's how I get the 13.5% here and the 13.5% here. And then 99.7% lies within three standard deviations. So 99.7 lies between three standard deviations. And so I get those area under the curves by taking the 99.7. I can subtract off the 95 I've already used, which leaves me with 4.7. 9 minus 5 is 4.7. And then I can take that 4.7 and divide it by 2, and that equals the 2.35. So that's how I get the inside here, 2.35%. And then to the left as well, inside this small piece here is 2.35%. Now, the outside, so outside the three outside the 3 standard deviations are this piece right here and this piece right here, the very small percent. So if you think the whole thing should add up to 100%, so 100% take away 99.7% leaves us with just 0.3% left. And so those represent the two very far ends. So 0.3% of the data lies outside 3 standard deviations. If you take that 0.3% and divide it by 2, that becomes 0.15. So I got to erase some of this here, but 0.15% lies outside standard deviation to the right, and 0.15% lies to the left of 3 standard deviations away. So very small percent of data lies outside that 3% or the 3 standard deviations away if the data is normally distributed. So here's an example where we can use this normal distribution. So the results from a chapter test show a normal distribution. The mean test score was 78 and the standard deviation was 6. Let's construct a normal distribution curve given this information, and then we'll use it to answer these questions. So the first thing I'm going to do is draw a normal distribution curve. So I'm going to try to draw it so it starts out low, peaks, and then comes back down. So just drawing a curve more symmetrical as I can, most symmetrical as I can, with the mean that is in the middle. And the mean test score was 78%. So that 78% goes right here in the middle. And then I go 3 standard deviations to the right, so 1, 2, 3, and 3 standard deviations to the left, 1, 2, 3. And then the standard deviation was 6. So standard deviation of 6 means that to get to the right, I take 78 and I add 6. So 78 plus 6 is 84. And then I add 6 again to get 90, and then I add 6 again to get 96. Going to the left, I'm going to subtract 6. So 78 minus 6 is 72, minus 6 is 66, minus 6 is 60. Then to fill in the percentages between 1 standard deviation, so 1 away from the right and left is 68% of the data, which gives me 34% in each. 2 standard deviations away is 95% of the data, which gives me 13.5% in each of these. 3 standard deviations away is 99.7% of the data, which gives me the 2.35 in this one and 2.35% in this one. And then on the outsides leaves the 0.3, so 0.15% here and 0.15% at the very end there. So that means that if I look at the test results, that there's only a 0.15% chance that someone scored above a 96 based on this data, or 0.15% that someone scored below a 60% chance. Now I'm going to say that I could say that there's a 68% chance that they scored between 72 and 84, the middle two there. So that's kind of how we use this data. So I can answer these questions here. So what's first question here? What is the probability that a randomly selected test score is between 72 and 90? So if I look at the area under the curve between 72 and 90, so 72 and 90 is right here. So if I look at this area under the curve between that, if I add that up, 34 plus 34 plus 13.5, that equals 81.5. So there's the probability that a randomly selected test was between 72 and 90 is 81.5% chance that the test was between those two scores. What's the probability that a randomly selected test score is greater than 90? Well, greater than 90 is here to the right, so that's these two right here. So the area under the curve there tells me that that would be 2.35 plus 0.15. And so greater than 90 would be 2.5% chance that the test that you grab is greater than 90%. So you might see these percentile ranks too when you look at your star scores. So if you're in, the 90th percentile or the 99th percentile, that's way over here on the normal distribution. There's about 2.5% chance or 0.15% chance that you fall in those categories. So if the star scores are normally distributed. We'll talk more about that in class. The height of 3,000 women, here's my next example. The heights of 3,000 women at a particular college are normally distributed with a mean of 65 inches and a standard deviation of 2.5 inches. So what about what percent of college women have heights below 70 inches, and about how many college women have heights between 60 and 65? So we are going to draw the normal curve out first and then use it to answer these questions. So if I can try to draw this, I'm going to try one more time as best I can. Try not to make it too small. So the mean goes in the middle, so we had a mean of 65 inches, and then we have a standard deviation of 2.5. So first I'm going to draw my 3 standard deviations to the right. So 1, 2, 3, and then 3 standard deviations to the left. 1, 2, 3. And then a standard deviation of 2.5 means that I'm going to take 2.5 and add it when I go to the right. So 65 plus 2.5 is 67.5. 67 plus 2.5 will be 67, 70, and then adding another 2.5 will be 72.5. And then going to the left, you're going to subtract 2.5. So 65 minus 2.5 is 62.5. Subtract 2.5 again and get 60, subtract 2.5 again and get 57.5. So those give me my bottom numbers. So to the left you subtract, and when you go to the right you add the standard deviation. And then between one standard deviation is 68% of the data. So I can fill this in as 34%, 34%. 2 standard deviations is 95% of the data. So 13.5 goes here and 13.5 goes here. 99.7% of the data between 3 standard deviations. So this was 2.35 and 2.35. And then you have the 0.15 left over on each side to add up to the 0.3 to make 100%. So then the first question, now that I have it drawn out, I can go back to my questions. The first question said, about what percent of college women have heights above 70 inches? So this one asked for the percent of college women heights below 70 inches. I read that wrong first, I think. So heights below 70 inches. So if I go to my normal curve here and find 70 inches, then I want everything that's below 70 inches. So that's going to include all of these data points to the left of 70. So I could start by adding those up. 0.15 plus 2.35 plus 13.5 plus 34. Whoops. 34 plus 34 plus 13.5. And if you add all of those up, you're going to end up with 97.5%. Now, there is another way to look at this, and that's kind of using that idea of like opposites or the converse, or, if I wanted everything below 70, and I know that everything under the curve here equals 100%, if I just found the area of, if I did 100% and did minus greater than 70, so instead of below 70, do greater than 70, that would be the opposite. So 100% take away what's greater than 70 would be just these two right here, 2.35 and 2.35 and 0.15. So that would be 100 minus 2.5, which would equal 97.5 as well. So that would be the maybe quicker way. So instead of adding up all the ones below, add up the ones above it and subtract it from 100. The next question says about how many college women have heights between 60 and 65 inches. So this one asked me for how many college women. So not the percent, but how many. And then I want between 60 and 65. So first, finding between 60 and 65 would be between 60 is right here and 65 is right here. So it's this area right there. So the percent of college women that are between 60 and 65 would be 13.5% plus 34%. So the percent of women that are between those two heights is 47.5. But it asked me how many college students. And remember that there were 3,000 women in this particular college. And so I wanted to know then what is 47.5% of 3,000. And to find a percent of a number, you times that number by the percent's decimal. Like if you wanted to find 50% of 100, you would take 100 times 0.5. So that'd be half of 100. So to find 47.5% of 3,000, you take 0.475 times 3,000, and that equals 1,425 women. So there's 1,425 women that are heights between 60 and 65 inches. Oh, shoot. No, I did that right. Okay, I was thinking I only did from 62 to 65, but I did go from 60. My graph is a little bit messy, so. Okay, that sounds good. Next example and last example. The number of nails of a given length is normally distributed with a mean length of 5 inches and a standard deviation of 3 inches. So let me first try to draw my standard deviation curve, and I might need to move it up a little bit. And then, okay, I'll put my middle right here, and then 1, 2, 3, and then 1, 2, 3. And then the mean length was 5 inches, and then it had a standard deviation of 0.03. So 5 inches goes in the middle here. And then I'm adding 0.03 to the right. So 5.03, 5.06, 5.09. And then subtracting 0.03, which would be 4.97, 4.94, and 4.91. There we go. That gives me that. And then inside, since 68 is between both, we have the 34% here, and then 95% between two standard deviations, so 13.5% here. 99.7 within 3, so, oops, I meant to put 2.35 here and 2.35 here. And then 0.15 on the very outside and 0.15 on the very outside. Okay, so now we should be able to answer the questions using our normal distribution curve. Question A says to find the number of nails in a bag of 120 that are less than 4.94 inches long. So this example might be, sometimes they use the normal distribution weights in like a factory, so anything that falls below or above a certain weight would be, put aside and wouldn't go in the bin where they are packaging the rest. So they wanted everything to be within 2 standard deviations of weight or length. Everything outside of that would be thrown. So that's just one example. So if I want to find the number of nails that are less than 4.94, that's right here, 4.94. And less than would be to the left. So that would be the percent of nails that are below that would be adding those 2% under that curve together. Would give me 2.5% of nails are below or less than 4.94 inches long. So if I wanted to find the number of nails, though, I would have to take 2.5 as a decimal. So moving the decimal over 2 to the left would be 0.025. And then take that times 120. So I'm finding 2.5% of 120 nails. And if I take that decimal times 120, I get 3 nails. So there's only 3 that are less than 4.94 inches long if the size of the nails are normally distributed. This one also says find the number of nails. I have 120 nails again, but I want to know that how many nails are between 4.97 and 5.3 inches. So the first thing I do is find 4.97 on my normal distribution is right here. 5.3 is right here. So that's right in the middle from here to here. So that is 68% of the data, 34 plus 34. And 68% of 120, I would take 0.68 times 120. And I would find that that would be 82 nails. So a large amount is between one standard deviation. 68% of the nails are between one standard deviation of the average size. So finding the number of nails in 120 that are over 5.3 inches. So same thing, but this time I want over 5.03 inches. So that's right here. And so I want these last 3 area under the curve. So adding up 13.5 plus 2.35 plus 0.15 would give me 16%. So then taking 16% of 120, I would take 0.16 times 120. And that would give me, it ends up being like 19.2, which is approximately 19 nails. Actually, should have mentioned that. I did these calculations earlier. So this one was the decimal 81.6, and I rounded it up to approximately 82 nails. And so 19.2, I rounded that down to approximately 19 nails between or over 5.3 inches long. Okay, so that is the normal distribution. So your homework is the normal distribution worksheet. If you have any questions or forget how to draw this thing, just let me know. Okay, have a good day.